Assalamu alaikum viewers, please like, share and subscribe this channel. Links of PDF files used in this video are given in description. So today is a part 5 of lecture series about nanomaterials, and in this particular lecture we will discuss in detail chemical vapor deposition or CVD. It is actually a bottom up approach for the synthesis of nanomaterials. So chemical vapor deposition method or CVD method involves a transport of reactant gases towards the substrate. Now in this diagram this is a substrate, and this substrate is kept at some certain temperature condition. Now the reactants come into the reaction chamber and they crack into different products which diffuse on the surface of this substrate and undergoes certain chemical reactions at appropriate site. So these either nucleate or these grow to form the desired films, coatings, wires and tubes on the surface of this substrate material. So this is the particular reaction in which we have taken some metal chloride and it is reduced into this metal and HCl, which is a side product. Now the HCl is a waste gas. It is removed outside of the chamber, whereas these metal particles, these are then deposited on the surface of this substrate. So this is the basic principle of chemical vapor deposition. The most common precursors that are used in chemical vapor deposition reactions are either these are metal hydrides such as silicon hydride and germanium hydride. These are either metal halides such as titanium tetrachloride, tantalum pentachloride and tungsten hexafluoride, or these may be metal organics such as trialkyl aluminium, tributyl aluminium, iron pentacarbonyl and iron and nickel tetracarbonyl. So these are the basic precursors, or we can use the reactants which are we using in order to deposit certain material or films on the surface of substrate. Following are the CVD reactions that are most commonly used, and there are three types. Number one is the thermal decomposition or pyrolysis. Number two is reduction, and number three is the oxidation. So first of all we will discuss about thermal decomposition, and it is also called as pyrolysis. For if we have to deposit silicon on the surface of substrate, then we will use silicon tetrahydride, and then it is thermally decomposed into silicon atoms and hydrogen gas. So this silicon is deposited on the surface of a substrate. Second is the reduction. So in this example we have taken tungsten hexafluoride, then it is reduced into tungsten particles which are deposited on the surface of a material, whereas hydrogen fluoride is removed as a waste gas. And the third procedure is which is called as oxidation. So in order to deposit silica on the surface of some substrate, we use silicon tetrahydride, and when it is oxidized it is converted into SiO2 or pure silica or quartz, and then hydrogen gas. This hydrogen gas is removed, whereas silica or quartz is deposited on the surface of a material. So a temperature around 300 to 1200 centigrade is usually used in chemical vapor deposition. So the source of this temperature, maybe it is heat, maybe it is in the form of light, or maybe it is in the form of plasma. So on this basis we have divided chemical vapor deposition techniques into following four types. Number one is the thermal activated CVD, and the source of in this type is used as IR radiation or radio frequency heating. Second type is called as photo assisted CVD, and in this type we are using arc lamps, carbon oxide laser and neodymium YAG laser and argon eye laser as a source of heat. Third type is called as plasma assisted CVD, and in this again we are using either microwaves or radio frequency diode to create that plasma. So this plasma is generated on a very small area. And the fourth and last type is called as metal organic CVD, and in this actually we are using organometallics as a precursors to induce chemical reactions. So these are basically the general types of chemical vapor deposition techniques. So whatever the type of CVD mechanism technique we are using, the mechanism or the general mechanism will remain the same, and it consists of actually 5 steps. So the mechanism includes, first of all, there is a transport of precursors into the reactors. So the reactants come into the reaction chamber. Then there is the absorption and diffusion of precursors on the substrate. Number third stage is that then these precursors react together or undergo chemical reactions at the surface of a substrate. Number four is that there is then deposition and growth of film as a result of the product which is formed after the chemical reaction of substrate. And number five and last is then transport of unreacted precursors and byproducts out of the reaction chamber. Now this step is very important in order to get purity in our final product. There are many advantages of using this technique. First advantage is that we can deposit almost any element or compound on a substrate. So CVD produces very dense films on the surface of the substrate. This procedure is economical in production, as if we place various products, so these all products are coated one in a time rather than one in a time, all these are coated together. So this is a very economical method. Now these coatings are also used for creating freestanding structures, and we can also create a nut like complex shapes. As we are removing the waste gases, so this is actually a self-cleaning procedure, and extremely high purity deposits are made on the surface of substrate. Almost 99.995% of purity is achieved by using this method. So the deposition is made homogeneously on the substrate surface, and also we can have a control over the thickness of the layer and also the morphology of the material deposited. Moreover, this technique is also used to form alloys. It also coats internal passages with high length to diameter ratios. So this technique is also used to coat the surface of the material with powders. So overall we can say that it is a very comprehensive method, and it is also time saving technique and also economically very favorable. There are various applications of the chemical vapor deposition method. So some are summarized here. So chemical vapor deposition can be used for the synthesis of nanotubes and nanowires. So here we are seeing here that this is a single wall carbon nanotube, and this is the multi-wall carbon nanotube. So both are used today in various structural units and electrical units, etc. Now chemical vapor depositions can be used for hard coatings and metal films which are used in microelectronics. So today is a world of microelectronics. We are seeing that the electronic things are getting small in small, and we have different surfaces of the materials that are used for different properties. Somewhere we have to create resistance, somewhere we have to create conductance. So all these materials are actually very thin in size. So in order to coat these materials with different products, we are using the method of chemical vapor deposition. Similarly, These CVD methods are also used for preparing semiconducting devices like transistors, resistors, etc. These devices also include such as the capacitors, and these capacitors are actually the energy storage devices. So the exposed plates of these materials are coated with chemical vapor deposition. Next application of the CVD procedure includes the energy storage devices such as the batteries, battery cells, fuel cells, and these fuel cells which are mostly used nowadays in cars, and similarly supercapacitors. Apart from that, whenever there is a high resistance of air, then the particles in the air can destroy the material, so we have to coat those surfaces in order to reduce the damage to the material. So we are also using CVT on wide range of industrial components, leading from aircraft blades to turbine blades. These are the gas turbines, and by the pressure of gas these move and produce electricity. Similarly, this is actually the timing chain pins, and these are most commonly used in automotive industry. As in case of cooking, we are seeing here that this is a grill. So radiant grills for gas cookers are also coated with chemical vapor deposition in order to reduce their damage. uh, Similarly, in case of adhesion of certain materials, the substrate is coated with adhesive material. So here we are seeing that there is the adhesion in which there is inward force between the material and the substrate. So here the green part is the substrate, and the blue portion is the adhesive substance. So we are using this adhesive substance to combine this carrier on the surface of a substrate. So these adhesive forces are only created if we make the substrate surface or the carrier surface ready for inclusion. Next, these are also used for semiconductor wafer or silane substrates. So here we are using a semiconductor wafer, and it has a lot of applications, and these are also used for biological microarrays, and these microarrays are used for the attachment of DNA, gene, protein, antibody, and tissues. So nowadays, there is a fusion between the electronics and the biological organs. So here, if we are seeing here that this is a prosthetic skin or artificial skin. Similarly, there is the prosthetic eye, and this eye is connected to the living tissues. Similarly, this skin is attached to the tissue. In angioplasty, we are seeing here that we are creating holes in the closed blood vessels. So all this is because of this electronics. Next, what we are using variable energy devices. What they are doing, they are not only measuring vital organs, but they are also storing their data. So this data can be sent to remote healthcare center by wireless communication. For example, somebody is going to have a heart attack, then the remote health center will be aware of that, and it will send the message to the person that he should take some emergency. Similarly, in drug delivery, we are using these electronics. For example, in transdermal drug delivery, these electronics are using control of electricity and heat. We can diffuse drug with our own requirement. So in this way, there is lot of going in electronics and biological organs, and in order to create a linkage between these biological organs and these prosthetic things, we need to have surfaces ready for acceptance of one another. So we are making their surfaces ready by using chemical vapor deposition techniques, so these reduce the drift in the device performance. uh, and last but not least, the chemical vapor deposition technique is also used for copper capping, which now this copper capping is used as anti-corrosive coating. So these were all the applications of chemical vapor deposition technique. So mainly in case of coating of thin materials, we are basically using this cheap method, and so these are the applications of chemical vapor deposition. So this was all about today's lecture. I hope you have well understood this lecture, but if you have still confusion, let me mention in the comments. I will respond to your queries as soon as possible. Okay, thank you. Allah Hafiz.